Calculus, getting ready. So here is question number 10, and I'll keep it till question number 10 in this particular series. So this is the last question for you to get ready for calculus. And here we have a function f of x equals to square root of x. Now you need to find domain and range of g of x, which is equal to 1 minus f of 4 minus 2x. So try to do this problem, and if you have any difficulty, then you can look for my solution. Now in these 10 questions, actually, I have provided the solution. But the idea is that you should first try it yourself. You can stop the video, try it yourself, and then look into my solution. So in case you don't feel comfortable, or in case you need some more practice, then you should definitely look into the playlist, which has numerous questions similar to this, right? So we have advanced functions, polynomials, and transformation videos, which should help you in this. What I've also done is that in this playlist included worksheets where they're titled with prerequisite skills. So there also I have given set of questions on each and every topic. So after going through these 10 examples, you can actually practice those. They will help you a lot. So they are kind of compiled in the same playlist to help you out. Now, how to do this? F of x is square root x. So let's first sketch our function, right? So it's kind of a review for you. So square root x, you know how it looks like. So square root x is a function which is something like this, right? Correct. So that is square root x. And now what is domain and range for square root x? Now we know domain for square root x is, so I'm not writing full form, we should normally write x belongs to real numbers so that x is greater than or equal to 0. Okay, let me write. And range is y belongs to real numbers where y is also greater than or equal to 0. So that is for our function f of x, correct? Now this function f of x is being transformed, and the transformation is given to you here, right? Now you need to find domain and range of g of x. That is the question. Now many times I've seen students making a huge mistake, and that is the reason why I'm considering this question once again, right? So what we should do in such cases is we should write this in a familiar form. Familiar form is kind of like this. We say g of x equals to, we always see this part first, right? So we'll write this part first, minus f of, and I'm putting square brackets, 4 minus 2x plus 1, right? So that gives you, well, this is vertically 1 unit up, and this is reflection on x-axis. Another mistake which students do is they don't factor here, and then they end up with wrong answers. So you have to take care of this also, correct? So let's do that part. So we get minus of f, and we'll factor out what? We should factor out minus 2. Since we always write x first, so we'll factor out minus 2, we get x. And when you divide 4 by minus 2, you get minus 2, right? 4 divided by minus 2 is minus 2. So that is what you get, plus 1. So that is the form which you are familiar with. So once you get this form, then you are comfortable writing your transformation statement, right? Kind of. So how does the point transform? Or how does the graph transform? So let's see either of them. Let's see the graph first. Okay. So in the graph, what happens? Minus, we'll go from left to right, okay? That is another thing. You should always go left to right when you are sketching transformed functions. Or you can go inside out. So there are two approaches, inside out or left to right. I prefer left to right. So minus means reflection on. This minus is vertical. Both these terms are vertical. So reflection here will give you a reflection like this, right? So that takes care of minus thing, step number 1. Now the step number 2 is another minus, which is reflection on y-axis, right? So this is y-axis, correct? Let me write x and y. Okay, so this is y-axis, and so it gets reflected here, right? So it gets reflected here. So that is my second one. Now the third one is times 2. So 2 inside we always do reverse kind of, right? So this 2 I will do horizontal thing in a different ink, right? So let's do it in green. So this 2 is compressed horizontally by a factor of half. So basically you bring each point inside. Do you see that? And so you get kind of curve which is like this. So that is minus f of minus 2x, correct? So we have done that part. But we have two translations. One is 2 units to the right and 1 unit up. So let's do that translation now and complete this transformation. So 2 units right and 1 unit up. So this point, which is at origin, right, changes to 2 units right. Let's say we have 1 and 1. 2 units right. 2 units right and 1 unit up. And so first thing is 2 units right, and second it goes 1 unit up. So here, so this curve, the green line, shifts here, and what we get here is this. So that is our transformed final function, and let me call this as g of x, correct? So from the graph you can provide the answer, and the answer is that domain is equals to, so this point was 2 for us and this is 1 for us. So domain is x belongs to real numbers where x is less than equal to 2, correct? And range, let's say range y is y belongs to real numbers so that y is less than equal to 1, correct? Y is less than equal to 1. So that is how you get transformation. Sometimes you may be asked, like, if there's a point here, how will that point get transformed? So let me use a test point here. Let's say our point is 4 and 2, right? Where square root of 4 is 2, correct? So when x is 4, you get 2. So how will that point look on your function, which is transformed, g of x? So what really happens is, so let's write down how this points get transformed, right? It's kind of a review for you, right? Horizontal x points will get multiplied by minus half and add 2, right? So we have 4 times minus half, and to that you add 2 for this particular question. So this is what the x point will be. The y point will get multiplied by minus, since there is a reflection on x-axis, and add 1. So for 2 it changes to minus 2 plus 1, correct? So that becomes the change coordinate. Let's say our point given here is P, and this is P dash, the transform point. Then the transform point will be as shown to you, which is basically, now you can do the calculation. Let's say P dash will be half of 4 is 2 with minus sign. So minus 2 plus 2 becomes 0, right? And here we have minus 2 plus 1 minus 1. So that means this point is minus 1, right? So that gives you a very accurate point right on the, so this is called when x is 0 and you get y value, y-intercept. So that point in the transfer function should be 0 minus 1. Well, that's like a lot of stuff I've talked about here in transformation. Now it's time for you to look into these worksheets which follow. So I started simple worksheet which we have even sketching, distance, time graph. You know, that's kind of important, right? And factoring, rationalization, piecewise functions. Such things are discussed: inequalities, polynomials, and rational functions. And most important is rate of change. Instantaneous rate of change is probably the most important, correct? So all those worksheets are after this. So go through them, practice, and in case you have difficulty, you should look into related videos. That should be good to go with calculus. And now we will start with calculus limits. Okay, thanks and all the best.